Well, welcome back to RDWorks Learning Lab. Now this session was planned to be all to do with something called the bitmap handle, which is quite a powerful tool for handling graphics. Something I failed to do in the last session. But as a result of the last session, what I found, I was struggling to get enough power to cut through a project that I'd previously cut very easily. If you remember in an earlier session, I show you a graph that I constructed, which was using a program that I wrote to check the depth of cut versus the speed of running. I feel that we must repeat that test now to see just what has happened to the lens and the power of the machine. We're going to write a program to test the cleanliness of the lens effectively. It will certainly test the efficiency of the light path. Now, to write this program, we are going to use quite a few of the things that we have learnt already. So we're going to draw a line, and we'll start somewhere, and we'll make it approximately 60 or 70 millimeters long. And we'll do that with the control key down so that it's dragged nice and straight and vertically downwards. So that's 2, 4, 6, say 7, and we don't have to be too fussy. Click. And now we want to produce several copies of that, so we'll click on it to put the handles on it, and then we'll use Control C instead of going up here to do the copy and paste command, and then we'll move along approximately to 10 millimeters, and we'll put a Control V command to paste it. Control V, Control V, Control V, 5, 10, 15, 20, 25, 30, 35. There we go. Now, they're not very easily and evenly spaced, so if we put the marquee around the whole lot, we can come up here and we'd be using this tool. We wondered what it could be used for, the across tool. Put it on any one of them, and look, it's evenly spaced them out. And now we can put the marquee around it again, and we can come to these other tools, which are the vertical alignment tool or the horizontally aligned tool. We click on any one of these, and hey, we've now got a lovely evenly spaced pattern. I'm going to choose this one, black, which it already is. Then this one we're going to put on a different layer, which will be blue. This one will be put on the next layer, red, green. I don't know what that is. Yellow and pale blue. Pale blue. There we go. So now we've got 1, 2, 3, 4, 5, 6, 7 different layers there, and they all appear up here. Now what we need to do is check these layers to make sure that they're roughly the right sort of speeds. So we're going to make that first one there, that black one, it's a cut layer. We need it we only need it 5 millimeters. Cut, yes. Speed, we're going to make it 90 and 90, and that's it. Oh, and that's it. Okay, now we do the blue layer, and we do the same thing again. Yes, this time it's going to be 10 millimeters a second, and it's not a scan layer, it's a cut layer, and we don't want it 30-40, we want it 90-90. Okay, and now we go to the red layer, and 15. Cut, yes, 90-90. Okay, the green layer, and finally the blue layer, which is going to be 35, and cut, yes, 90-90. Okay, if we take a look up here at the program, it's going to do 5, 10, 15, 20, 25, 30, 35. So we'll save that to a program file, a machine file called lines. Save. OK, and then while we're here, because we might need this program again, we shall save it up here as well as a drawing file. Right, so let's go to the machine. So I'm going to check whether or not I'm losing power by comparing cut depth results with what I did when the machine was fairly new. About 1 psi, there we go. Extractor fan on, and away we go. So this is down at 5. Well, I don't think there's any doubt there, is there? When you look at the bottom set of results, they're approximately supposed to equivalent. So we've got about half the depth that we had initially. So my guess is my running without air has caused the lens inside there to fog up. So let's go and have a look at that as a first stage. To get the head off, oops, you have to loosen it off, because there's a sort of like a split clamp collet behind there, and then we can pull this down, and then that's how we adjust it. You have to be very careful because there's a cable behind there that's on full stretch. These are not tight yet. And we can just about stretch it to get it out. We'll disconnect the air pipe, and we shall probably have to take the fitting off, I think, because I won't be able to unscrew that unless I reset the pointer. So now, oh, there we go, that's come out quite easily. And I don't quite know what I'm going to find in here because it's the first time I've had this out. Oh, there's the lens. So there's the lens in there, and as you can see on that side there, hopefully if I catch that in the light right, that's quite shiny. Right, we've got to unscrew this little clamp ring at the top here. And then carefully, because I don't want to scratch the lens in any way. Looks like a rather special lens anyway. Ah. Well, it's certainly not shiny on that side, is it? It looks as though it's covered in some sort of film. So let's just have a quick wipe over it with a clean. That doesn't help a great deal. Here we've got some isopropyl alcohol. Just squeeze some alcohol on there and see if we can clean the surface. The answer is a bit. Definitely some sort of mark in the middle there where the laser beam has been going through, I presume. Whether we can take that off, we've taken some of it off, so maybe that's just a bit of a heavy mark on there. So let's carry on and see if we can wipe it off. Oh, it's virtually gone now. That's good news. So it's just something burnt onto the surface of the lens. Just the merest hint of it there when I catch it in the light. So we do it one more time. Clean piece of paper. The lens is now in a nice, clean, clear condition. So we'll carefully put it back, curved side downwards. Just check inside the nozzle there. It doesn't look like a load of fumes and stuff in there, but it probably won't take much to coat that lens. It's amazing how little there was on there and how much effect it had on the cutting power. To get that in there, I think I'm going to turn it upside down to get it flat on the back face, because it doesn't want to go in square. So we'll put it in upside down so that it sits flat. There we go. So we lock that in now, We won't put the fitting on for a minute. We'll make sure we've got to get this set right so that we can just about squeeze that into there and get it back into its fitting. There we go. We'll put it to the top. Doesn't matter where it goes because the laser is running parallel light all the way across here and down here until it hits the lens, and it's only when it hits the lens does it start focusing. So regardless of the length of this piece of pipe, it doesn't change the focus length of the lens, it just changes the length of path that the light goes through. But then again, moving this changes the length of the path that the light goes through, so it doesn't matter where you set this. Hopefully you'll be able to see as I cut the different depths, if I can get them beside each one of these. So we'll do an enter to start, and then I might have to pause it to I think I'm one out. And I think you can see the comparison here. This one after lens cleaning, that one before lens cleaning. That's the difference that small amount of debris on the lens made to the depth and quality of the cut. So it is essential that you keep the lens clean. I haven't cleaned the mirrors, just the lens. Now if I put these back to back, this was when the machine was brand new virtually, and this is now after I've just cleaned the lens. I would say they're pretty well back to normal. There's been less than an hour of running on that lens, and I suspect that probably maybe 10 minutes, 15 minutes of it has been without the air on. So maybe I'm doing the damage quickly. I shall make sure I keep the air assist on now, and we'll check how it goes in the future.